In this screencast, I want to go over a couple of core topics that we've been exploring with our soundboard project in class. I'd like to extend this and illustrate how we can use multiple arrays to be able to find a dynamic soundboard that we can extend and play around with further. So where we left off with class is that we have a soundboard that has two inputs from the keyboard that allow us to press the Q key and the W key, and it plays and visualizes two different sounds, which is pretty cool. So this is an exercise in learning how sound works in P5.js, how arrays work, and how classes work, and how they enable us to make objects in our system. So there's a lot going on here. There's a lot of really interesting topics that we're exploring through this seemingly simple sketch. So what does our code currently look like? We have a setup function that really doesn't have much going on, right? We create our canvas, which is the normal flow, and we create two pads. Now we say new pad here, which is the way for us to construct, or what we call instantiate, our class into an object. And we've defined our class down here. We're calling it a pad, and we made that up, right? So that's a completely creative name, and we can call it anything we want, which is kind of cool. So we can create like our own vocabularies within our software itself. So we called it a pad, and kind of like synonymous with a button on like maybe a drum machine or something like that. And we have a constructor that goes ahead and leverages some of the sound objects in the P5.js sound library. So we learned how to use the oscillator, the envelope, and the analyzer, or P5.amplitude, to be able to test the actual sound levels coming out of the pad. And the pad also has a draw and play function, which we call methods when we're talking about a class. And all we do here in the play is we go ahead and set the frequency to the object's frequency, and then we play the oscillator. The draw method simply just grabs the level and then grabs the height of that level, maps it between the height of the actual pad size, and then draws a rectangle. So we can actually see a visualization of the sound going up and down, which is kind of cool. You could probably do a lot of interesting things like that, like maybe a circle in the center of the screen and have just one circle animate, or maybe both going on at the same time. But now, in order for us to create more pads, we'd have to go ahead and manually create a new pad. We'd have to go ahead and map a new key code in the key pressed function. And it would be very manual. So if you think about a system that maybe had, all of the keys on our keyboard, there would be a lot of pads listed out here, and our code would be pretty messy to play around with. So there's a better way to do this. And in this video, I want to introduce the idea of multiple arrays working together to be able to define the whole system. So right now, we really only have one array, and that array is this notes array, right? And this notes array contains the frequencies that we want to play when we hit a certain key. So right now we have 3 notes in this array. Now the keys that actually are pressed are hard-coded in this key pressed function. Now what if we took an array of keys and matched it with an array of notes, and then was able to loop through all of the keys or notes to build all the pads that we need to build? Then, to create more pads on our soundboard, all we'd have to do would be to add a new key and a new note, and it would automatically show up. Okay, what do I actually mean by that? Let's see. So if I go ahead and we'll go to the top here, and I suggest you guys play along with me, get in your environments. You should have this same exact code. There's a link in the video below. And I'm going to say let keys equal an array. And I'm going to say the keys array will equal to 81, 87, and I'm going to put a couple more in there. I'm going to say 69 and 82. Now remember, these are key codes that we can grab from the key code variable here. That is a global variable that reports back the actual number code of the key that was pressed. So in this case, we're listening for Q, W, E, and R. Awesome. So now we have an array with 4 keys. We only have an array of 3 notes. So why don't we go ahead and add one more note here. I'm going to add a lower frequency note. Maybe I'll add like a 60. Let's see what that does. Awesome. Now, instead of going ahead and looping here, instead of manually doing this, we're actually going to loop here. But we need one more thing. Instead of having pad 1 and pad 2, I'm going to go ahead and take these out. I'm going to create one more array. And this array is going to be empty at first. And it's going to hold our pads. So remember, the array is really just a list of information, right? There are these buckets that are linked together that allow us to store information within them. So by creating these arrays, we're just creating places to store things so that we can manage them in our code in other places. And you're going to see exactly how we're going to do this in a minute. So instead of having these individual variables that represent a pad, we're going to now make a list of pads based on the keys and the notes that we've defined in the system. Awesome. Let's see what this looks like. I'm going to take the pad 1 and pad 2 out of the setup function, and I'm going to turn to our trusty for loop. And now I'm going to make a for loop. I'm going to say for, open parentheses, and I'll say var I equals 0. So we'll make a small looping variable here, and I'll say I is less than the size of the keys. So this is really interesting. So I could say keys.length. Now, keys.length, because the array is kind of like an object, right? It is an object that we can use that has different properties that we can grab from it. One property is the length. This is going to return how many pieces of information are in that list, in that array. So in this case, it's going to return 4, right? So we have 1, 2, 3, 4. So we're going to loop from 0 to 3, which is going to be 4 indexes, right? Remember that 0 indexing in arrays, which can get a little confusing at times. So I'm going to go ahead and say I++. We're going to increment by 1 each time. I'm going to open up a new code block here. And now we're inside of our for loop. Now this for loop is going to execute 4 times because we're reading the length of the keys. So that means that we can use the I variable to populate our pads array and build new pads based on that length. Okay, that sounds kind of crazy. Let's see it in action. I'm going to say pads sub I. So this is going to be sub 0, this is going to be sub 1, sub 2, and sub 3, all on one line of code. Similar to us saying like what we were doing before, we said, you know, pad 1, pad 2, pad 3. We were doing that manually. Now we're making the computer do it for us by using our knowledge of loops and arrays and combining them together. Mega powerful stuff. So let's go ahead and say pad sub I is going to equal to a new pad. And now we're going to give it its frequency. Now here's where we tie these two arrays together. So instead of giving it some hard-coded frequency, which every single pad would be the same exact sound, let's dip into the list of notes that we have. So I'm going to say notes sub I. So for sub 0 and sub 0, so pad sub 0, or the first pad, is going to have a key of 81, which is Q, and a frequency of 220, right? And etc. It's going to go up. So 87, 330, 69, 120, 82, and 60. So by making this dynamic, we can go ahead and actually make a list of pads. Now, we have to give it also an X and Y position, right? Because our pad takes an X and Y position. So the X position, we'll keep this simple. We'll make the X position, we'll start it out at 0. Or I'm going to actually create a new variable for this because we're going to want to line these up, right? So we're going to say X and Y. But now we're going to have to go ahead and create an X and Y variable up here. So let's go ahead up here. Actually, we could do this in the setup because we don't need to x equals 0, and we'll say y is equal to, we're going to say y is equal to the pad size, right? Because we want to be able to, if we said y is 0, it's going to be everything's going to happen above the screen. So we're going to say y is equal to pad size, and then on each loop, we're going to say x plus equal pad size. So this is the same thing as saying x, if I long form this, I could say x equals x plus pad size. So that's a nice little shorthand, plus equal pad size. So that means x will increase by 100, because that's what pad size is equal to, as we defined up here, after every loop. So we should have a bunch of pads lined up against each other at the top of the screen. Now we're not going to actually see that yet, right? Because we just set up our pads, but we didn't actually draw them yet. So let's dip down into our draw function, and I'm going to take out these pad1.draw, pad2.draw. And what do you think we're going to do? We now need to loop over all the pads and draw them, right? So we're going to do the same exact thing that we're doing up here. So I'm going to go ahead and copy this in our setup, bring it back down here. And now, instead of creating new pads, I'm going to simply say pad sub I dot draw. And we don't want to do that incrementation, so we'll take that out. All right? So now we're using a loop here. We're using a loop here. We have one more loop. We have one more loop we want to test. And that's going to be in our key pressed, right? So here we have this hard-coded key code equals, key code equals. This is all hard-coded stuff. We're done with that. We want to make this dynamic. So let's go ahead and we're going to copy this for loop again. Same exact thing. We're going to get rid of all these keys. And we're going to take this out. Well, format this properly. And let's give it a little space to breathe so we can see it. Okay, so now we're looping again, and now instead of drawing here, we want to now test whether or not the key code is equal to any of the key codes that we're listening for to be able to play, right? So now, here's where we go full boat. Now we're going to combine a conditional statement. So we've got objects, arrays, functions, looping. We're doing everything here. This is awesome. So let's go ahead and say if the key code, which is our global key code variable we have access to, equals keys sub I. So we're testing to see if the key that was just pressed is equal to anything in that list. And this is where some of the magic that when you're first learning this stuff kind of disintegrates a little bit, because computers are fast. So we're literally looping over every single one of these keys every time we hit a single key to be able to see which one was actually pressed. And when we start to talk about some particle systems and things like that that are doing these amazing graphics, a lot of times that's what's happening. It's looping over everything, and because of the massive scale, it creates this beautiful visualization. But it's really one by one checking this stuff out, which is kind of crazy. So if the key code is equal to any of the keys in that list, then we're going to say pads sub I dot play, right? Because if we found one, right here, we found a hit, right? If this resolves to true, then we know we need to play the pad that this key defines. And it's all being indexed by this I looping variable. So now, pad sub I dot play. Now notice something. We didn't actually change anything in that class that we defined. And this is going to sound weird, in class. So we defined this in class, and we don't have to go ahead and actually change any of this. We're just changing how we make them, right? How we use the actual class we defined. So with this in place, let's see what happens. Let's go ahead and run our sketch. Now if I hit the Q, Oh, it worked. W should be next to it. E. Ooh, there we go. We're lower frequencies. And R. There we go. So we have 4 and they're all playing. Awesome. Now, check this out. This is where the power lies. So what I'd like you guys to do, hopefully you got to this point, played along, and was able to get this going. If not, rewind the video, pause it. This is why I wanted to create these videos, so you can slow it down as slow as you want, or speed it up and skip things if you need. But if we want to now go ahead and add a new key, right? And I think, what was that site that I had? Keycodes.info. Right? Say we wanted to add T. I'm going to hit T. So T is 84. Now, I want to go ahead. All I have to do is say comma 84 and then give it another frequency. Say, I don't know, let's go high. Let's go 400. I'm not even sure that's going to do anything, but let's see. And then let's go ahead and rerun this. Now I should have 5. There it is, the T. Now it's just time to jam out. Awesome. All right, cool. So I'm gonna post this to the class. Suggest you guys play along. We basically are showing you how to use arrays to be able to define dynamically this soundboard. So think about how maybe you can modify this. Maybe change how the draw function works in the pad. You know, play around with that. Maybe make it a circle or something else. Maybe play around with the different frequencies. There's also a couple of cool functions within the P5 sound library that allow you to convert MIDI sounds to frequencies. So instead of doing this oscillator.frequency, we could convert a MIDI number to a frequency. So if you guys had maybe a list of like a song in MIDI, we could convert it and play it through a system like this, which is kind of cool. So I hope you guys enjoyed this, and definitely play along. All right, thanks guys.